So how do I rewrite this starting with A? So to start with A, you just start with A. Start with A right there. And then just go to the right or the left. It doesn't really matter. It works both ways. So I'll go A, E, D, C, B, A. A, E, D, C, B, A. So I started at A. I went E and then back. Or go the other way. Start at A and go left. B, C, D, A, B, C, D, A, B, C, D, back to E, back to A. E, back to A. They're both the same loop, run clockwise and counterclockwise, right? Same loop.
Literally, just use any number. It's the same thing, right?
Use any number?
Same starting point. Like
any letter, yeah. Right, any starting city. Any starting city. It's the same loop, but I'm doing it with A because the answers are in A. But yeah, you're right. You're right. Same loop wherever you start, just a loop. Yeah, so then which of those answers is it? It was the A, B, C, D, A. It was the B. Yep, it was answer B. So everybody see how I finished that up? Right, when I will have one city left, open ends connect E, I write my loop, and then I rewrite it in terms of A, because the answers are in A, and I write it both directions, right, because it's the same loop, done clockwise or counterclockwise. I wrote both directions, and I look for either one of those answers, so that's always how we finish. Is that good? Test on this is Wednesday, day after tomorrow. It's never long here in the 4-week summer session. I feel like you'll be able to do that? Cheapest link kind of question. Nearest neighbor, repetitive nearest neighbor, all those different things. Don't get that? All right. All right, all right. Actually, having said that, there is, how should we go about it? There is one other thing I should show you from that material. Yeah, I better. Even though we finished it up, we haven't totally, completely. Would it be best to do it today? And then, what's our schedule? Then tomorrow's the practice exam. Right. Yeah, so maybe I better. Yeah, so let me just call that thing up here real quick. Surprise, But they are on the exam. So let's talk about it. So I'm going to kind of finish up. So the game plan today. Where's my pen? I didn't bring my pen for some reason. I one of these probably dead pens. So today is what? Monday. So the Monday plan, we're going to work on chapter 8 basically, probably, I don't know what. Did we finish 8.1? We did, right?
Yeah.
8.2, probably work on 8.2. So really we're going to do a little bit of practice exam number 3 right now, just small amount. And then we're gonna do 8.2, a lot of 8.2, probably even some of 8.3. Probably some, not all, of 8.3, mainly chapter 8. All right, because our exam on Wednesday, you have the schedule, right? The exam Wednesday is chapter 6 and 8. 6 and 8. Okay, so look at this. They got big old mileage chart. Is that thing making sense first off? What that chart's even talking about? For example, what does this 795 mean? Let's make sure this chart's making sense first off. I'm not sure I'd write the whole thing down. It's so much. It'll be on the YouTube. You can check it, I mean, you might definitely want to, but it's a lot to write down. It'll be on the YouTube. It's on the, it's a practice exam. So you've got, on the web page, first page, practice, you saw me grab it, right? That's where I got it from. And you'll take it in class tomorrow. All right, anyway, but one of these is on the real exam. So I don't want to surprise I aim to not surprise you. So one of these mileage charts is on the exam. So what does that 795 mean, first off?
Distance between Dallas and Atlanta.
Right, everybody good with that? Right? That's the connection with Dallas and Atlanta. That means 795 miles from Dallas to Atlanta, right? Why is the 795 also here? Because that's a chart, Atlanta to Dallas, same thing. So all the numbers repeat because they repeat, right? Because it's the same cities. So, all right, so you with me? So what are we supposed to do? Nearest neighbor algorithm, it means recipes, steps, right? Nearest neighbor method applied to it. So nearest neighbor. So how do I do that? How do I do nearest neighbor? So forget about the chart for a minute. What if I just gave you a map? Boom, boom, bunch of cities connected with some map thing. Whatever, blah, blah, blah. What would be the first thing you do when they say nearest neighbor? I want to make sure you're good with just that idea.
Start with what's closest to you.
You got to know where to start. You gotta know where to start. Yeah, what's closest to you, but where are you? So that's the first thing. Aside from the mileage chart, that's just the idea. Nearest neighbor, you got to have a starting point. Now, does that make any sense? What I'm saying, if they said repetitive nearest neighbor, you don't have to care so much about your starting point. Why not? They all make loops. All these methods are making loops. How is repetitive nearest neighbor different than just nearest neighbor?
Cheapest.
You're going to do all of them. You're going to have them all be starting points. You're going to repeat, right? You're going to say A is the starting point. Now let's do it with B. Now let's do it with C. So you're going to repeat, right? Repetitive nearest neighbor. So you don't care like what the one starting point is. You're going to try them all as starting points for repetitive nearest neighbor. That's question, right? I think that's one. They're just saying nearest neighbor, not repetitive. So I'm just going to do it once. I'm just going to have one starting point, take the cheapest road every time, come back, right? So where do I start? I got to know where to start then. I'm only doing it once. Yeah, how do we know? Yeah, we read, huh? Right up there. But I know that seems silly, but a lot of people get right there, the ball game's over. Right? Right there, the ball game ends for a lot of people. It's a quick exit, right? So look up there and you go, oh, round trip that starts and ends at Memphis. So they're telling you up here. Does that make sense? So you got to get that. All right, so good. So with that in mind, so we're starting and ending at Memphis. So if we're starting and ending at Memphis, and we're doing nearest neighbor, you know what nearest neighbor means, right? Just your nearest neighbor every time, right? So if you're starting here at Memphis, which neighbor is closest to you? What's the closest trip?
Atlanta.
Yeah, there's 371 to Atlanta, right? Because from Memphis to Atlanta is 371. It's further to all the other cities from Memphis. Now, I could have looked at Memphis and went across, or I could have looked at Memphis and went down. These are the same numbers as these, aren't they? Either way you like to look at the chart. They're repeated, right? All the numbers are up there twice. I know sometimes that confuses people, though. But anyway, so 371. That's the cheapest, closest city to Memphis. So I'm going to go over here, and I'm going to start writing myself a little map. I really encourage you to do this. This will help. Memphis. I can't spell Memphis without looking at it. Memphis to Atlanta. I simply mean just write the two words with a little line. I know that might seem goofy or whatever, but people were really missing it before I started showing them this, and this really helped them. All right, next. Now we're at Atlanta, right? We traveled from Memphis to Atlanta. That was the cheapest link. Well, I'm sorry, I'm using the words. That was the nearest neighbor. It is also the cheapest. But anyway, it's the nearest neighbor. Okay. Who's next?
Houston.
Yes. Now you're at Atlanta. So put your line by Atlanta. Right. You're here at Atlanta. You're looking at these numbers. Which one is closest? Well, Memphis, but we've already been there. So who else is closest?
Houston.
Is it? Oh yeah, you're right. Houston, 789. That's a little bit lower than the other ones, huh? Houston. Anybody see that? It's the lowest number from Atlanta other than the Memphis number, right? Nearest neighbor. Good? Easy enough? See how this works? Now we're at Houston. Can you do the next link? Go ahead on your paper there. You're at Houston. Go to your closest neighbor from Houston. So if you're at Houston, who's your closest neighbor? Dallas. Gonna go to Dallas. So now we're at Dallas. So what's next? Now we're at Dallas, and the closest one, it's Houston, but we can't go back to Houston. So it's Memphis, but we can't go back to Memphis. So yeah, it's Kansas City. Everybody see that? Am I going too quick? Is that okay? I'm just reading the numbers for Dallas. How far is everything from Dallas? The two closest, of course, were Houston and Memphis, but we've already got them. So it's on to Kansas City. So I'll just break it down here. I'll just say KC. On to Kansas City. Now, do you realize at this point we should stop working? because we only have one city left. Remember, when any of these methods, you get down to one city, there's no choices, right? We have 1, 2, 3, 4, 5 cities. There's only 6 total in the thing, right? Count them. 1, 2, 3, 4, 5, 6 cities. We have 1, 2, 3, 4, 5. We only got 1 to go. When you only have 1 to go, there's no options with any method. The 2 unconnected open ends need to hit that last city, don't they? They have to, because you got to make a loop. You got to hit all the cities. So take Kansas City, take Memphis, and hit Denver, which is the only city you haven't hit. Those 2 have to hit Denver. There's your loop, your nearest neighbor loop. Is that okay? Does that make sense? Now, which answer is right? Let's see. Is it A, first off? Memphis, Atlanta. Is that right? Yeah, that's so far so good. Denver. No. Not Memphis, Atlanta, Denver. That's not right. Let's go. So it's not A. Is it B? Memphis, Atlanta, Denver. No, it's same problem. Not B. It's not A, not B. Is it C? Memphis, Atlanta, Houston. Yeah, Memphis, Atlanta, Houston. Houston, Dallas, Kansas City, back to Denver, back to... Yeah, it's option C. See, it is. It could have gone forward or backward, though. So you got to, got to be careful. It could have gone the other way. But anyway, there it is. It's good. Questions on that one? We good? How about, would it be worth our time to do cheapest length? Why don't we do that quick? So you guys okay with that? I'll erase this. And I'll just go to a fresh screen. And I'll say, okay, try cheapest link. That's question 21. Try cheapest link. Go ahead, let me give you a second. So how's cheapest link different? All right, so what's the first thing we grab?
Memphis.
How do we know? What are we looking? What's the plan?
We read. Oh, well, I thought you were talking about like a question.
What's the first bit we're going to grab? Smallest one.
Yeah.
Smallest one that's connecting to Memphis?
Oh, it's just small stuff in general.
Right, not the smallest one connecting to Memphis. So everybody get that difference? That's the key difference. Remember, cheapest link is global. It's not just located at one city. That's the fundamental thing that makes people stumble on the 2 methods. Everybody see the difference? With nearest neighbor and repetitive nearest neighbor, you start at some particular point, and you're only looking at the numbers connected to that point. Right? You see the difference? Nearest neighbor, repetitive nearest neighbor, you're always at a certain city, and you're just looking from that city. What's my nearest neighbor from this city? Right? Yeah. In fact, the name kind of gives it away, right? Nearest neighbor. Well, that implies you're sitting somewhere and you got neighbors, right? Whereas cheapest link just means lowest road anywhere. Anywhere. So what's the lowest number on that whole thing? Is it? Is it 371?
No,
249? Yeah, that sounds right. Where is it? There. 243? 243. Here it is, the lowest number on the entire chart. Remember? Cheapest link. See the difference between those? So grab that one first. What is that? That's Houston. I'll write it up here. Start. Especially with cheapest link, it's helpful to write it. That's Houston to Dallas, or you could write Dallas to Houston. It doesn't matter what order, but that's a link connecting Dallas and Houston, right? Either order doesn't matter. Good? Now grab the next lowest number up there. Anyway, it doesn't have to be from Dallas or Houston. That's the difference. Everybody see the difference? Cheapest link, you're always looking global. You're looking everywhere. Not just from your house at your neighbors.
I'm assuming we pick like the first lowest, then the second, then the
Sure.
third, and then the fourth throughout the whole chart.
That's right.
Okay.
Watching out for the two no-nos. Right? Remember the two no-nos. You can't make a loop too early that leaves somebody out, and you can't have 3 roads hitting one city. Yeah, as long as you don't violate the two no-nos, just smallest number, next smallest, up the line you go. Exactly. So what's the next number? 371. Yeah, 3. And if it confuses you, you can ignore these because they're just all repeated up there, right? I'll just look at these ones in the lower left. They're all just repeated on the other side of the diagonal. So 371, right? That's the next number. That's the Memphis-Atlanta connection. Memphis. And again, you can write it either order. Doesn't matter if you put Atlanta first, then Memphis, whatever. But notice they don't connect with Houston and Dallas. Doesn't matter. Well, they'll eventually connect. Right? Now, so you see the difference between cheapest link and nearest neighbor? Nearest neighbor, you're at your house, right? When do you think about your neighbors? From your house. You look at your neighbors and pick your nearest neighbor. Cheapest link, you're looking global, the whole thing. All right, 371. What's the next number? So go ahead, let me let you do a couple steps rather than me just get more out of it if you think it yourself. Is it cold in here? Crank up that AC, don't they? We could always just open the window, though.
I'm assuming we can't.
Yeah, we're in the basement, huh?
Oh wait, never mind.
So what's the next number? Is it 450? Oh, 41. You're right, 41. If we can take it anyway. This is the next number. Can we take that? Kansas City, Memphis? Yeah, I got no problem with it. I'll just make a connection off of Memphis. Don't make a whole brand new Kansas City, Memphis. We already got Memphis. So just connect it to the Memphis you already got. That's fine. And you can, there's nothing magical about how you can go sideways or whatever. It's just the connections that matter. Yeah, that's the next one, huh? No violation of anything. No 3 roads hitting any one city. No premature loops. Right? Good. Grab the next one. Grab the next one. Keep going.
Kansas City, Dallas.
What's the next one we should try, though? First off. I mean, it might. The next number. What's just the next number? How about that?
452.
452, right? It's not going to work, but it is the next number. Let's look at it.
There it is.
Right? 452. Why is it a no-no?
3 lines out of Memphis.
Yeah, it's Dallas to Memphis. Here's Dallas. I've already got Dallas. It'd be that connection between Dallas and Memphis. And why is that a big no-no? 3 roads hitting Memphis now. 1, 2, 3. No. Can't do it. So don't do that, right? We're not going to hit any city 3 times. We're going to go in and out twice. So what I would do on my chart to help is I would just cross it off, just so you know you've looked at it, but we had to reject it. So keep moving. What's the next number? I don't know what the next number is. Hey, actually,
Line 61.
could we stop at this point?
Yeah.
We've only got one city left. Now, it's not quite as simple as some of the other scenarios, but we could focus on that city. I don't know, it might be confusing at this point. But what is the city that's left? Denver. So what is Denver? Denver. Denver's the leftover city. Now, there's a lot of ways Denver could play into this, isn't there? But it's got to be a Denver connection, doesn't it? So it's got to be Denver. So looking at Denver, what's the lowest number from Denver?
780.
Yeah, the lowest Denver number is 781. Looking at Denver and looking across.
Dallas, Denver.
Oh, wait a minute. No, it's the 600.
Wait.
I'm not, because I crossed off the other half. This is confusing. I'm not doing this in the easiest way. Sorry. Maybe we should ignore that. Just keep moving. Maybe that'd be better. Let's keep moving. So 452 didn't work. What's the next number? 489? I'm sorry, I'm changing my game plan. 489. That's not going to work.
Kansas City.
Okay, because that's Kansas City, Dallas. Oh, no, that'll work.
We can connect it.
I don't know. I'm having all kinds of problems. Yeah. Sorry, guys.
It's a Monday.
Yeah, I guess so. Yeah, so I'm trying to change strategies. Yeah, so I guess it's not always easiest to just jump to the last city, not when you got a weird thing like this. So let's just keep going with the normal method and forget all my special shortcuts because they're not helping. So the next number is 489. It is a keeper. It's Kansas City to Dallas. Look at that. It's perfect. Kansas City to Dallas. Now it would be very easy to bring in the last city because now we have two clear open ends, Houston and Atlanta. They got to hit the last city, Denver. What else can you do to make a loop? So now would be the time to do that. Everybody see how it wasn't so clear before?
And then Denver's the one that connects to Kansas
Yeah.
City.
Right. Denver has to hit the two open ends, right? So I'll put in Denver. It has to hit here, and it has to hit there. Not Kansas City, it hits Atlanta, right? Has to hit Atlanta, the open in Atlanta and Houston. It's got to. See how there's no other choice? Once you have a whole string and then just one city, boom, they got to hit those open ends to make a loop with Denver. What else can happen? So there it is. So now they want all the answers, they wrote them in terms of starting with Memphis. So if you start with Memphis and go to the right, you got Atlanta, Denver, Houston, Dallas, Kansas City, back to Memphis. So which one of those is that? Is that A? Memphis, Dallas? No. Is that B or not A? Memphis, Atlanta? Yeah, that works. Memphis, Atlanta. Houston? No. No. It's not B. Memphis, Atlanta, Denver? Memphis, Atlanta, Denver, yeah. Houston, Dallas. Houston, Dallas, Kansas City, Memphis. Yeah, it's C again. Yeah, C. Is that good? Everybody see how we do cheapest link? You're getting more comfortable with those? Nearest neighbor, cheapest link. Nearest neighbor, cheapest link, right? On a big map kind of thing like that. Is that okay? Make sure, so that's... yeah, right, okay. Now we've been through all those. Yeah, let me just make sure. Just the last little concepts. Okay, number 30. Number of Hamilton circuits in the complete graph with 100 vertices. There's a formula on your 3x5 card. Well, maybe will be.
Is this 30?
For like KN, which stands for complete, even though it's a K. I don't know why. Number of circuits. Number of
circuits is
n minus 1 factorial. Is that what it is? Thank you. N minus 1 factorial.
Is that KN?
Yeah, KN. Stands for complete. Spelled badly. KN. Complete. That's when they say complete graph. It's KN. Formula, just put this on your 3x5 card. N minus 1. N's 100. They're saying 100 vertices. So 100 minus 1 factorial. That's 99 factorial. You guys have your calculator? We'll hit 99 factorial. And you'll get an answer that's crazy big. Like Google. You guys know what Google is?
A Googleplex, you mean?
Yeah, it comes from that. Yeah, well, there's Google and then there's Googleplex. Do you know what Google is? You know, Google, the website, came from this. You know, the website we all use all the time. Google means 1 with 100 zeros. That's what it means. 1 with 100 zeros. What's this number? What do you guys have? What's this crazy big number?
It says error.
Does it just say error?
Just me a second.
Just error. Forget it. Don't even try that. Huh? Okay, anyway, crazy big. Yeah, Google means 1 with 100. People that came up with the Google website, they were math people, and that's why they named it that. They actually spelled it different than whatever. Who cares? The official spelling. But it's 1 with 100 zeros. They were saying Google's going to go everywhere, and sure enough, it has, hasn't it? So anyway, so what's our answer to this question? So this is bigger than Google. Thousand. It's in the thousands? No. In the millions? Like, no. More than a billion? Absolutely. It's more than a billion. It's way more than a billion. It's crazy more than a billion. So. 31. Complete graph, 12 vertices, number of Hamilton circuits, what? Oh, 12 vertices. So it's just n minus 1 factorial again. So it's 12 minus 1. So it's 11 factorial. So there it is. D. That's easy. Okay. Let's keep going. Good with that? Just 11 factorial, right? It's just 12 minus 1 factorial. Number of circuits. Good, good, good. N minus 1 factorial. Okay. So 32. The brute force algorithm for solving the TSP, traveling salesman problem, is, so brute force. So remember the other day when I wrote out whether the methods were fast or not fast, or gave you the right answer, the actual best answer or not? Remember that whole discussion? Right, I assume? You didn't think about anything else all weekend, right? Sorry, I'm just joking around. All right. So we had the brute force, and then we had all the others, which was like nearest neighbor, repetitive, nearest neighbor, and cheapest link. Remember, brute force was optimal, meaning it gave you the best answer, right? Optimal means best answer. It's the way to get the actual best answer, but it's crazy inefficient. It's slow, even for supercomputers. Remember, that's what that calculation was all about. Supercomputers would take hundreds of years. So brute force is best answer, but it's not fast. It's crazy slow. That's why people in the real world don't use it. The other methods, all three of the other methods, were approximate, meaning they were not exactly the best answer. Not exactly the best answer, right? They just give you a pretty good answer. But they are efficient, meaning they're quick. At least for computers. They might be slow for us. But computers can smack them out in seconds when you program them to do those methods. Make sense? That was what it was all about, learning, how that works. So that'll answer all these questions. 32. The brute force algorithm. What's the brute force algorithm? Is it approximate? No. It's optimal. Optimal and inefficient. Yep, C. So if you just have this on your 3x5 card, you got it automatically. Number 33. Nearest neighbor. Nearest neighbor, like all the other approximate methods, is approximate and efficient. D. It's not exact, but it's quick. Right? And then 34, cheapest link, same thing. It's approximate and it's efficient, right? The other three are all the same. They're not exact, but they're quick. That good? That's chapter 6. And we'll go on to chapter 8. We good? We're all happy? Questions on that? All right, let's go forward on that then. All right, here we go. Chapter 8. This takes a real deal on chapter 8. Project consists of 8. Remember what chapter 8 is all about. This section of the course is all about management, right? We just dealt with how do you manage like a company like FedEx or UPS where they got to visit a bunch of places. Use those algorithms. They program. Now we're talking about how do you manage a bunch of employees that have a bunch of different tasks, and you want to get the job done as efficiently as possible. We're going to use math to help with that. Project consists of 8 tasks labeled A through H. Processing times and precedence relations for each task are given. I'll explain all that. So basically, task A takes 3 hours to do. Maybe, or those could be days. I don't know. Let's just pretend they're hours. Right? So task A, job A, takes 3 hours. Job B takes 11 hours. That's what this chart means here. Job B takes 11 hours, but the F here means it's a precedent task. What does pre mean when it's in front of any word? Before. It's a task which must be done before. So you got to do F first before you work on B. So this could be like, the common example is always, a construction manager, right, who's managing the building of a house. He hires a bunch of subcontractors, to do the different parts, right? So the contractor is not going to hire the roofer to come out before the plumbing and the walls and the foundation are in, right? That he would just show up and leave. So that's the kind of thing we're talking about. Certain things need to be done before other things. And so whatever this job is, F must be done before B can be done. And B is going to take 11 hours, but he can't start B until F is already done, right? C is going to take 2 hours, but you have to get F done first. D is going to take 5 hours, but G must be done first. E is going to take 4 hours, but C must be done first. F is going to take 8 hours, but A and H must be done first. G is going to take 7 hours, but F must be done first. H is going to take 6 hours, doesn't have to have anything done first. So make sense out of that chart? That good? What they're meaning when they give us these little charts? This is real life, you know, how real life jobs go. Take different, so this is what a manager would do. They'd lay out the different jobs that need to be done, the things that need to be done before them. All right, what is the vertex set? So that's why we got these tools last time, these directed lines, right? So what's the vertex set? Remember what vertex means? It just means your points. Just fancy word for all the points. So it's just A through H, A, B, C, D, E, F. And there's also start and end. We're going to throw in start and end now. So A through H, start and end. What is the arc set? The arrows. Now, I don't see any arrows. What are they talking about? Arrows. What it is every time you have a precedent task, that's an arrow, right? Let me go up here and check this out. If F must be done before B, what does that mean? F is going to point to B. I'm going to make a diagram in just a minute that'll be much easier than using this chart. That's why we came up with the tools of the arrows, because they're easier to do these problems for. So that means F is going to point to B in a minute when we lay this out as an arrow diagram. Right? Because F will lead to B, right? You get F done, and then you can do B. Right? You get the walls up, and then you can have the roofer come out, kind of thing. Right? Whatever those jobs are. And then F is going to point to C, and G to D, and C to E, and A and H are both going to point to F, and F to G. Arrows from bottom to top. Everybody see that? Arrows from bottom to top all the way across. So, let's see how it's B. I've already done it because, and then the start. How do you know what the start is going to point to? I don't see start up there. The start will point to anything that doesn't have a precedent task, that doesn't have something else that must be done before it. Are you hearing me? Am I doing the wah, the Charlie Brown teacher voice here? Or are those words coming through loud? Because you have to catch those words. Those matter, what I just said. You know the start points to anything that doesn't have anything else before it. Right?
No matter what, they're going to have to start with A and H.
There you go. Exactly. Yeah, because A and H have nothing before them. That means you could start with those jobs. You can't start with anything else. You can't start with B because you have to do F first. You can't start with C because you got to do F. You can't start with D, and on you go. The only things you could start with are A or H because they don't have anything that must be done first. They have no precedent tasks. Right? So the start will point to A, and it will also point to H. You can start with jobs A or H. See how we know that? So therefore, start A, start H. See how that is? And then A points to F. Is that true? I think so. Yeah, right here, A points to F. That's true. B. Now, how do you know B points to the end? I don't know what. Yeah, we don't have to worry. But yeah, you're right. It's because B isn't before anything else. You don't need to worry about all that. Yeah, technically you're right. B is not before anything else. So B doesn't lead to anything else. It must lead to the end. Does that make sense? That's correct. Yeah, good observation. William, right? Good observation, yes. And all the rest, you could check them. They're all good. I don't want to waste too much time. That's not the main meat and potatoes. Is that good? I think you'll be able to identify that. Is it okay if I flash off of that? Everybody good? Because we do want to get... Okay. So which one of these maps really reflects this job chart? So how do you know? Well, I've already answered it C. You can see. that this is the answer. Why is that right? Let's take a close look at it. The start dot points to A and to H. And that's right. Start in A and H, huh? The start goes to A and to H. And A points to F and H points to F. That's right. A and H both point to F, don't they? Remember how that works? And that's what we have here. That arrow and that arrow. A and H are both pointing to F. The parenthesis numbers, that's how many hours the jobs take. F takes 8 hours. That's right. Right? And then F points to C, B, and O. Is that true? Yeah. F points to B, C. Oh, did I say O? Yeah, I'm wrong. C, B, and G. C, B, and G. There we go. Sure enough, F points to B, C, and G. F points to B, C, and G. That's right.
I'm gonna assume it's alphabetical.
What do you mean?
Like, mine has like CB and FB, and I'm assuming A goes before C, right?
No, it's just the arrows. Yeah, good question. I'm with you, Carl. Nothing about the alphabet matters. It's just the arrows that tell the order.
Okay.
Just who leads to whom by the arrows. Really good question. Yeah, it's not, you can't just do the alphabet or reverse alphabet or anything. It's the arrows. The arrows dictate who points to whom. So then we get those three. And then finally, C goes to E. Is that true? Yep, C goes to E. There it is. B goes to the end. Yeah, B doesn't go to anything else. G goes to D. Yep, G goes to D. We put them in up there. G goes to D. And what did I just say? C goes to E. That's true. And that's all those arrows, huh? And then, C goes to E. G goes to D. And then B goes to the end. And so do the other ones. F and D. Well, no, I mean E and D. Yeah, E and D also go to the end because they don't lead to any other task. So that's right. That's the right map. That map represents that chart, doesn't it? That's what we're going to learn to do. We're going to learn to take this kind of table and make that kind of map. It's actually not that hard. I'll show you step by step. It's pretty easy. The hard part will be then taking that and mapping a whole job out. That's the real stuff that we want to get to today. Is that good to there so far? Yeah, in fact, rather than me just kind of piecing it through, that wasn't a very good way to teach that. I mean, it was okay, but let's just do it ourselves. It'll be better. It'll be better than me just going, yeah, see, it's right. Let's just do it. Let me show you how you just do it. You just start drawing those arrows. So you put your start here. Let's just do it ourselves. Because, this will be the one test that, this chapter right here, I'm going to give you questions that are not multiple choice. Because it's just too tedious, try to look through each of these little things. I'm just going to say, hey, here's the table, just draw me one. And it'll be easier, you'll see. And so let's just draw one out. So here we go. How do I know where I'm going to go from the start? I'll pretend I don't even see this because on the test there won't be, this part anyway, won't be multiple choice. The other chapter will be. But you can see the practice exam. It's not. This part won't be. So anyway, so how do I know where to go from the start? Well, who doesn't have anything before him? A and H. No precedent. Right? They both have nothing before them. Nothing that must be done before them. So they can be started with. Right? So A and H. So you just do that for stuff. A and H. Make sense? Now, how do you know where to go from there? Well, now you find A and H down here and notice that they both point to F, don't they? A and H both point to F. See, and I just keep track of the connections as I go. Does everybody see that? I'm going to fill them in as we go. When I'm done, I'll have every arrow that goes from bottom to top. Now, am I going too fast? You with me? Now, where does F go? F goes to B,
And
to
G.
C, and to G. Yeah, so from F go to B, C, and G. Now, I'm probably not making it look exactly like they made it look, but that's fine. I'm going to those three, so that's good. I went to B, C, and G. Everybody see that? That's what shows, that's what's in my chart. F goes to B, C, and G. See that? Now where do you go from here? Well, what arrows do I have left? G to D. I need to go G to D. So how do I go G to D? Well, just shoot off and go to D. G to D. I need to go C to E. Okay, so shoot off and go to E. C to E. What, is that it? I think I've covered them all, haven't I? Yeah, there's no more arrows. Do you guys see how I know I've covered them all? I'm just simply counting them down, right? F to B, as I went through, I just did every connection. I showed an arrow, and when I did it, they're all done. So the last thing to do then is to put the end on. So let's go over here and put the end. And how do you know what point's at the end? Any dot that doesn't have an arrow coming after it. So that would include the B, and the E, and the D. Done. That wasn't too painful, was it? Does that make sense, how we did that? I just went through my chart, made sure I had all this. I didn't put the numbers in there, but you could do it with the parentheses, that's obvious, right? Is that good? Questions on that? All right. All right, so here we go. 8 experiments need to be carried out. One of the experiments requires 10 hours to complete. 2 require 7. 2 more, 12. 3 of the experiments require 20. In addition, the 10-hour experiment cannot be started until both the 7-hour experiments have been completed. The 12-hour cannot be started until all 3 of the 20-hour have been completed. Draw a project diagraph. It's called a diagraph for the directed arrows. Diagraph for this scheduling problem. Okay. I've already answered that this is the right answer, not that. But how would we know that?
I mean, I would say put it out and just follow the instructions. It's kind of like how, someone likes some piece of cake sometimes more than someone else. I just kind of feel like that.
Yeah, we just got to map it. That's true. All right, let's go through it. But the key words, the most important thing is the precedent stuff, meaning what must be done before what. That's the crucial information. So let me just jump right to that part. Where does it say that? Okay. The 10-hour experiment cannot be started until both of the 7-hour have been completed. So who must be done first?
The 7 hours.
So I've got both of the 7-hour things, and they both point to the 10-hour thing. You agree with me? I'm just going to start right there. See how I came up with that? They said the 10-hour cannot be started until both the 7 and 0. So both the 7 point to the 10. Do them first, then you can do the 10. Is that good? Next, the 12-hour cannot be started until all 3 of the 20-hour. So the 12-hour cannot be started until all 3 of the 20 have been done. So you got 3 20-hour experiments, and they all point to the 12-hour. Is that right? The 12-hour experiments, there's more than one, cannot be started until all 3 of the 20 have been. So all 3, how many 12-hour experiments are there?
2.
Oh, yeah. 2 more require 12 hours. So there's 2 of these. There's another 12, and they all 3 point to that one also. And how many 10s are there? Oh, just 1 is a 10-hour. 2 require 7-hour. Yeah, I got those.
How many comes in handy to know the total number?
2 more require 12. And 3 require 20. Yeah, I got that. Okay, so it's all good now.
20 have to come before 7.
How do you know?
It says up there.
I'm not seeing it. Cool, I'm not seeing it.
Why did I read it wrong?
Yeah, the 2 7s lead to the 10. Is that what you said?
Yeah.
Yeah, I've got that. Yeah, I got that right here. 2 7s lead to the 10.
None of the 7 hour. Oh, I'm on my math. My question says different.
Oh, different. Okay, got a different one. Yeah. Okay, so that's basically the map right there, other than the start and the end. Does everybody see how I did that? So now you just got to put on the start and the end. How do those fit in? Well, the start's over here, the end's over here, and the start points to anything that doesn't have something else pointing to it. So that'd be these guys, right? And then the end is, from anything that's not pointing away, like that. Good. And that is what? Is that what we have here? Yeah, that is this answer, isn't it? So it's the same thing. Everybody okay with that? Making these are called digraphs, directed graphs. Have those direction arrows, right? We okay? I'm going to move on if that's okay, because we still need to really get to the real thing, which is putting in the times. Okay. So a project has 11 tasks, 11 different jobs that need to be done. So a schedule of 4 processors produces a finishing time of 29 hours. Hold on there for just a minute. So processors is the number of people working on the job. So processors is the number of people working on the job. So if you have 4, processors, people or computers or whatever it is that are working on the job, 4 people working on the job, and they finish in 29 hours. How much idle time, and that's the goal in all this, is to not have idle time. Notice if you're the construction manager and you call out the guy that's going to put up the walls too early, and the foundation guys haven't quite finished the foundation, then the guy that put up the walls is going to stand around doing nothing while you pay him to be there doing nothing, right? So you want to minimize idle time. That's good management, is to minimize wasted time as much as possible. That's how Caltrans gets things done so efficiently. Sorry, I can't help it. Joke around a little bit. Caltrans. Can I here? Let me turn off the record. Back to business.
It's like putting in the paved thing like on the side, so it looks like you like paved over someone, and it was just funny.
Okay, I hadn't heard about that. All right. So anyway, the whole thing is to minimize idle time, right? Good management, no wasted time. All right. So think with me. If you have 4 people working for 29 hours, how many total man hours or woman hours or people hours is that? Whatever 4 times 29 is. Was that 36, 8, 9, 10, 11, 116 hours? You with me? Right? Because there's 4 people and they worked 29 hours on the job, right? See what I'm doing here? I just took the number of people working times total hours. 4 people worked 29 hours, 116 total hours on the job. Well, how many hours, if you add all these up, add up to equal, can somebody do that? What is that? 17, no, I can't. 24, 25, 30, 40, 46, 54, 59, 66, 70, 80? 80. I think it's added to equal 80, if I did that right. So they add up to 80 hours, right? If you add up all the jobs, I just added up all the jobs that need to be done. And this is their hours for each of the different tasks. Added them all up, came out 80 hours, right? How many hours did people work? Or supposedly work? 116. So a bunch of those are wasted hours called idle time, right? Just subtract. So 116 minus 80, was it 36? And that's how I got that answer. 36 hours wasted idle time. Everybody seeing what I did there? Just took 29 hours to get the whole job done, times 4 people, 4 processors, is 116 man hours. And then I added up all the tasks. They should have only taken 80 hours. So that difference is wasted idle time, bad management. That's the whole purpose we're here for, is to use math to make the management more efficient, less idle time, less wasted time. Try to use math to help that. So, good. Now, we haven't actually scheduled anything yet. We're about to. But that's just like analyzing the results. If that was how it went, that'd be 36 hours of wasted time. Choose Vertex. If the tasks are executed in alphabetical order, therefore the project takes at least, what? I don't know what they're saying. Explain why a schedule with 4 processors must have a finishing time greater. Why must the finishing time be greater than or equal to 20 hours? I'm on part B now.
Because that's what.
Because why? 4 people is going to take 20 or more hours to get all the jobs done. Do you see why? Because there's 80 hours of work up there. Right? You with me?
That's some extra work off.
Yeah, so now what we're saying is, if there's 80 hours total tasks, right? I added up all the tasks up here, got 80, right? And there's 4 people working. If they work perfectly, don't even waste any time at all, it'll be 20 hours total, best case. Right? It's going to be at least 20 hours. There's no way they're going to go get a job done lower than 20 hours, because four people working for 20 hours is 80 man hours of work. And we have 80 hours of tasks that need to be done. So there's no way you're going to get an answer that takes less than 20 hours to complete the whole job with 4 people. That's what it's going to take, best case scenario. So we just know what we're aiming at. That'd be the best perfect management, is if we could do that in 20 hours for 4 people. They'd get 80 hours of work done and all the tasks done. That would be amazing efficiency. Make sense? I'm answering those 2 questions. We good with that? I move on from there. Really want to do is these project timelines. So, all right. So over here they're giving us a digraph, arrow digraph. Refer to the project described by the project diagraph on the right, using the priority list BAD, CF, EG. I'll talk about that. Schedule the project with 2 processors. Show the project timeline. Give its finishing time. Not multiple choice on the exam Wednesday. So, because like a ton of work. It's going to take us like 15 minutes probably to do one of these. So this is the big deal. Are you feeling ready? We have finally arrived. This is the main meat and potatoes. I'll give you like 4 of these on the exam Wednesday. It'll be like the last 4 questions. And you have to map out the whole chart for me, because that's the actual deal. Mapping out a job. All right, so let's do it. So they're giving me this project diagram. That's my blueprint. That's the main thing I'm going to follow. Okay? And let's start mapping out a job based on that. So how am I going to do it? I'm just going to come up here. I think I'll have room. Where do I have room? Maybe right? Yeah, we'll have room. That'd be good. I could just blow that up and whatever. This will be good. Okay, I'm going to do it right here. All right, here we go. So I'm going to have 2. They told me n equals 2 processors. That means 2 people are working on this job. Processor 1, processor 2. I'm the manager. I'm going to basically assign them jobs. You guys are the manager. We're going to basically assign them jobs according to this project diagram. So here we go. What jobs can we start with? Yeah, we can either start with A or B or C. You with me? We can't start with D, E, or the other ones. Right? We have to start with A, B, or C. Now, so for processor number 1, I'm going to give him job A or B or C. I have options, don't I? He can start with any of those. Right? He can't start with D, E, F, or G, but he can start with A, B, or C, any of those. How do you know, when you have options, how do you know which one to give him? Is that distracting for you?
I guess you'd say.
And the answer is, it's not just alphabetical. Sometimes it is. That's where we pay attention to the priority list. Now, this is what confuses people. They kind of get almost too focused on that priority list. The priority list, hear me on this, is only secondary. Primary, main thing is that arrow diagram thing. But if we're looking at the arrow thing and it allows us to have more than one option, then we consult the priority list. But the priority list is only a secondary thing. Okay, so right now I have options. According to the diagram, I can do A, B, or C. So I have options. So then I go, all right, which one should I do first? It says B is more important than A or D or C. So if you have options, do B before A. Okay, I'll do B. I'll do B. So processor 1, you get job B. How long is job B? I can't even hardly see it. What does it say? I gotta look up there. 5 hours. Processor 1 is 5 hours. That means I'm gonna say, okay, you're gonna work on job B. That's what that B means. And you'll be done after 5 hours. So I'm gonna make a timeline now. I'm mapping out a timeline plan for how the processors are gonna work on the various tasks and finish the whole job. Now, just to make this simple, no stopping a job partway through, and no combining on a job. Real life you can do that, but this math would get totally complex, and you need computers and software and all that kind of stuff. Keep it simple, still get the basic idea of what it means to use math to do this. So one job at a time, one person working on it, all the way till they're done. No stopping halfway, to make life simple. Okay, so processor 1 will do job B for 5 hours. That's processor 1. So we say, hey, processor 1, get going. Go do job B. So he takes off, starts working on job B. So now, processor 2 still needs a job, though. There's 2 options. A or C are both available. I cannot give processor 2 any of the other jobs yet, right? I can't give him D until A's done, for example. I can't give him E, and on you go. So the only ones available for processor 2 are A or C. Are you with me? A or C. You have options. If the arrow diagram gives you options, then and only then you can sort the priority list. So I'm thinking, should I do A or should I do C? Which one's preferred? A. A is preferred to C. So we'll give processor 2 job A. How long does job A take?
5 hours.
8, doesn't it?
8.
8. So that's further than 5, like right there, 8. So see how I just made the 8, I'm just doing the time chart things. 8 is further than 5. Give him job A. See what's going on. Is that good so far? Why is the B on top in the end one? Because B was preferred to A in the priority list.
Said he was first.
You always do processor 1 first. Just always.
So would you go C next?
Okay, now you ready? Now, here's the deal. You move. You always have to remember where you're at in time. That's always the trick on this. You got to keep track of time. So, this was time 0, of course. You move forward in time to the first completed job. Does everybody hear me on that? Move forward in time to the first completed task, I should say. So which task is done first? The B. So move forward to there, to 5. So move forward in time to 5 hours. So now I'm at 5 hours. What's happening right now at 5 hours? Job B just got done. Job A is still being worked on. Processor 2 is busy, still working on A. He's got 3 more hours to go. But processor 1 comes back to the boss's office and says, hey, I did it. I finished task B. I'm ready for something else. So what do we give him? Yeah. So come over to the digraph. This is the part that can confuse people. Remember, it takes a little practice. Remember where you're at in time. Job B is done. Let me cross that off. Job B is done. Job A is being worked on by processor 2. So let me just write processor 2 is working on job A. Use your digraph. It's the main thing. It'll help you.
C.
So what's available?
C.
The only thing available, correct, is C. Don't even look at that priority list because I don't have options. It's C or nothing, right? Everybody see that? Why? Why can't I give him D? Well, because you can't get job D. You can't even begin D until you're done with A. That's what that arrow means, right? You must finish the other thing first. Must finish the foundation before you put on the walls, right? You can't work on job E until C and B are both done. That's what that means. They have to both be done before you can do E. Yeah, that's the other thing that confuses people. Some people go, well, look, we just got B done, so we can follow the arrow to C. No. There's 2 arrows. There's 2 arrows, to E. I can't hardly see it when I look here. There's 2 arrows going to E, right? And that means both. You have to get both the walls done and the foundation done before the roofer shows up, for example, right? You can't just say, well, we got the foundation. We didn't quite get to the walls. It's okay. No, it's not okay. They have to both be done. All right, so that's what that chart means. So B is done. So the only option is C. And that's usually the case. You're not going to, most of the time, you're not going to be looking at the priority list. Does everybody hear me on that? Because in the past, when I've taught this course, People that get confused are people that spend all their time looking at the priority list. And they go, well, I'm supposed to do D next. For example, I've worked with them, and they'll say, Mr. Herron, it's B and A, and that thing says D next. Don't look at that priority list. That's only a secondary thing. Most of the rest of the time, we probably won't even look at it. It's the arrow diagram. That's where you want to focus. It's all about the arrow diagram. Only if he allows you to have more than one option do you then consult the priorities. Rarely will we even look at it again. It's this. What does this tell us? We can't do D right now. We can't do D till after A. Next, the only thing open, the only job open is C. Everybody see that? So I'm going to give processor 1, job C. Now, how long does job C take? 9 hours. So we're at 5 right now. Add 9 is 14. Just space it the best you can. I don't care as long as you just roughly tell what's after what, Job C. So I gave processor 1 job C. He'll be done at 14 hours. Right? Added 9 to 5. 9 plus 5, 14. Okay. Good so far? Now, move forward in time to the next completed job. That's always what we do. Move forward. So we're at 5 hours. Move forward in time. What's the next completed job? Right here. At 8 hours. So don't jump to the end of the 14. Go to here because that's the next completed job. So we're at 8 hours right now. What's happening right now at 8 hours? A just got done. Job A just got done. Erase this. This is done. Processor 1 is working on C.
And Henry has one other choice.
So processor 2 has come to us, says, hey, I finished boss. I finished job A. The boss looks up and says, hey, B and A are done. C is being worked on by processor 1. What's available to give processor 2 right now?
D.
Yeah, the only thing available is D. See how I'm not even going to look at that priority list? It's the arrow diagram. Only when the arrow diagram gives me more than one option do I even think about looking at the priority list. Yeah, the only thing the arrow diagram is saying is D. The only job available right now is D because A is done, D is available. E is not available right now because C has not been finished at this point in time. So yeah, the only job available is D. So give him D. D's a 12-hour job. So 12 plus 8, take him all the way out to 20, won't it? Give him job D. So I did that. I just took 8. I added 12 because D is a 12-hour job. Takes him to 20. That good? What do we do now?
Move on to
Move.
the next available.
Move forward in time to the next completed job. So if you're time 8, move forward to time 14. To time 14. And C is done. Job C just got finished. Come over here then and say, okay, job C, you're done. D is being worked on by processor 2. Okay, so processor 1's ready for a new job. What's available? Yeah, the only thing available, there's no options again. The only thing available from the arrow diagram is E. That's it. Nothing else. E. So I'll give him job E. See how I'm not even looking at the priority list anymore? It's the arrow diagram. So E is what? 6 hours? 6-hour job. So 14 add 6, 20. They'll both be done at the same time, huh? Give him job E. Coincidentally, they're both done at 20 hours. Everybody see that? Because E was a 6-hour job. 14 add 6 is 20. Good? Move forward in time to the next completed task.
Would you go to processor 2 now? Or does it matter?
Well, they're both available,
So it
right?
doesn't matter.
So it's always number 1 first. If they both show up at your office at the same time, just like in the very beginning,
Priority.
number 1 comes before 2. If they're both available at the same time, it's just number 1's before 2. Right? So what just happened? E is done and D is done. Both E and D got done at the same time. 20 hours. We're 20 hours into the job now. And 2 jobs are available. Right? F and G. We have options. Processor 1 is first. Processor 1 is first. When they're both available. So they're both available. Processor 1 is first. Which one? So we have options. You guys seen how I'm going to actually go to the priority list because I have options. F and G are both available. Which one am I going to give to processor 1? F or G? according to the priority list, F comes before G. So I'll give him F. F's a 1 hour job. He'll be done at 21. I give G a 2 hour job to processor 2, be done at 22 hours. And that's the whole job. So at 22 hours, this thing will end, right? And the only idle time, I'll do it right there, that is the 1 hour idle time, right? There'll be nothing for processor 1 to do that last hour. That's pretty good. That's very efficient. We didn't hardly waste any time. Sometimes you'll see we'll do these charts, and we'll have big blocks of idle time. So that was only 1 hour of idle time. The whole job's done in 22 hours. That makes sense? That's this right here, this little map we just did, right? That's B. Everybody good there? See how we did that? Good, good, good. Questions? Hard one. Come back to it. Let's just try another one of these. Okay, so there's our question. They want you to do this one. 2 processors. The priority, you always have to have a priority list. Priority list, it's called the decreasing time algorithm. Algorithm, remember, just as a steps to get something done, like a recipe. So decreasing time algorithm. What does that mean? That means if you got a couple options, do the job that takes longer first. Get started on it first because it's longer. That makes sense? Decreasing time. For time, your priorities go down as time decreases. Does that make sense? Let me write that. Decreasing time, which means start at highest time job, then go down. But careful. That's just the priority list. That's not very important. Don't get hung up on that. It's mainly the arrow diagram, right? That's the main thing. All right, so let's give it a try. So we have processor 1, processor 2. Let's make a little chart. So let me let you guys see how you guys are doing. So, all right. So, processor 1. So first off, we start. Here's the start. What jobs are available? A, B, or C. They're all available. They can be worked on. Not D. D says you can't work on me till you get A and B done first. And E says you can't work on me till you get C done first, and etc. Right? So the only jobs available are A, B, and C. So how do you know which? So we have options, right? If the arrow diagram gives you options, that's when you go back and say, all right, what's my priority list? My priority list is decreasing time, which means start the highest time and decrease. So if you look at A, B, and C, who's the highest time job? B. B is 9 hours. So processor 1, you get job B, it'll take you 9 hours on that. You don't need to write like the 9 in here like that. I wouldn't put it in there at all. Doesn't matter at all. You just care about the time on the bar, on the line. Jenna.
So then, on a different problem, like for if it was, different, I guess.
Right.
The A, B, and C, would that always be like the first?
Yeah, well, whatever comes off the start, it has to be one of those right off the start.
Okay.
So is that your question?
Yeah.
It does. Yeah, it has to be one of those right off the start.
Okay.
Yep. And the reason we're doing decreasing time is because we're going with the general idea that, well, bigger jobs, we're trying to be efficient about this, right? Bigger jobs, get working on those first. Turns out that's not really all there is to it. That's not going to be the most efficient way, but it sounds sort of good at first. We'll learn more as we go. But anyway, so far so good. We're going with the biggest jobs first. Now, so we give processor 1 job B, because those are the only ones available off the start. Okay, so next, processor 2, he needs a job. Okay, well, A and C are both available. How do you know which one you're going to give processor 2, A or C? A, because A is the bigger job. 8 hours. A, 8 hours. Now draw these guys, you want to be careful. This is simple. It's going to get way harder. It's going to be 3 processors, all kinds of fancy times, fancy priority lists. You want to be careful. And you want to do, carefulness doesn't just come out of nowhere. Carefulness comes from intention. So now just write it, and I'm not a very neat writer. Look, I'm sloppy. I've had people put in my reviews, he writes like a kid. It's fine with me. But, so I'm saying, you don't have to be a neat writer, but make it big, draw the numbers in places you can see them, right? So it's not necessarily being perfect penmanship, but it's habits of big writing, careful writing, writing the numbers where you can see them, things like that. Do those things. Don't cut these corners. You won't need, when you come to the test, you won't need to go faster. You'll need to be more precise. You'll miss questions because you're not careful about things, not other things. So be careful. So write the numbers like I'm writing. Write the chart like I'm. Don't cut those corners. All right, so now what do? We go forward to the first completed job. What's the first job done? The A. The A is the first one done. Right? Don't jump. See, a few people stuck the C up here. That's not right. That's not right, right? Because the first person available for a job is processor 2. He's ready an hour before processor 1. So he comes back to the boss and says, I'm ready for another job. So let's go up here. Are there any jobs available for him? At this point, job A is done and processor 1 is working on B. So you just have to kind of put yourself in time. Where are we in time? Job B is being worked on, A is done, so what's available? C. Put C down here. Now, it's a 5-hour job, so add 5 to 8. That'll put me at 13. See how I came up with that? Only C is available. It's the only job available. Those back jobs, D and E and stuff, are not available until we get the ones before them done. Okay, so now go forward in time to the next completed job. What job is done next? The 9-hour job, right? So now the 9-hour job is done. B is finished. Go back up here. B is finished. And C is, processor 2 is working on C. So A and B are done. At time 9 hours, A and B are done. C is being worked on by processor 2. What jobs are available? Only D. Only D. So there's no choices. I'm not going to look at any priority lists. There's only one job available. That's typical. 6-hour job. D is a 6. So take 9 and add 6. That's 15. See what I did there? I added 6. It's going to take 15 hours. All right, go forward in time to the next completed job. What's the next completed job? Here, I'm at 9 hours right now. Go forward in time. The C is done at 13. With me? So job C is done. So get job C out of the way. C is done. D is being worked on by processor 1. At 13 hours, right? I'm at 13 hours right now. So what's available at 13 hours? E is the only job available. Everybody seeing that? E is the only job available. So I'll give E, it's a 12-hour job. So add 12 to 13. That'll take me way out here, 25. I added 12 because E is a 12-hour job. Is that good? Move forward in time to the next completed job. That's 15 hours. What happens at 15 hours? D is done. E is being worked on. What's available? F, yeah, only F, not G. Does everybody see that? G is not available because E is still being worked on. Only job available is F. It's a 2-hour job. So it'll go from 15 to 17. With me?
So that whole time in between will be idle time?
Yeah. Because think with me now. Follow the process. So we're at 15 hours. I'm at 15 hours right now. Go forward in time to the next completed job. What's next completed? F. Right? That's the next. And what happens? F is done then. So come over here. F is done. So what's available? Nothing. Because processor 2 is still working on E at that point in time. Everybody see that? So let me camp there for just a second. These are the kind of mistakes people make, right? And it just takes practice and carefulness. Processor 2, right? So you got to kind of have the snapshot of that point in time. You got to realize what's going on at that point in time, right? Right now, at this point in time, processor 2 is working on the E. And all these jobs are done, including F, but G is not available. G is not going to be available until E is done. Just because there's somebody else that wants to work, too bad. The arrow diagram says you got to put in the walls before you can put that roof on. Sorry, roofer, stand aside and wait while I pay you whatever per hour, because that's just the arrow diagram rules, right? It says you can't get going on G until E is done. We should have started on E earlier, shouldn't we? That's part of the greater wisdom we'll get. You should look down the road at the bigger numbers down the road, not just the immediate. We shouldn't have started with that 9 just because that was bigger than 5. We should have looked down the road and said, yeah, but there's 12 behind it. We better get going on that road, or people are going to be waiting around. That's part of the wisdom of a better manager. Okay, which we'll have another technique about that. Yeah, Jenna.
So did we just choose to go A, B, C, D, like we were going in alphabetical order, but you don't always have to go?
No, it had nothing to do with alphabet.
Okay.
No, and I didn't do it. I started with B, actually.
Okay, yeah, so.
Because B was bigger time. B and A were bigger time than C. That's why.
Okay.
Because this is decreasing time.
Okay.
Yeah. But sometimes they will say alphabetical.
Yeah.
Yeah, they can tell us whatever. They give us a priority list, and they'll say, hey, do it alphabetical. Or, hey, do it, this one's decreasing time, which means highest time, 9. That's why he went first. And then next, 8. And then we waited on the C. But I'm just pointing out that really wasn't wise. Well, the best method we're going to get is called the critical path algorithm, which we'll get, maybe even today, where we'll look down the road, and we'll add up everything down the road, and we'll say, go the road that has the highest total road. That's more wise in your management decisions. But anyway, let's just keep going. Everybody good to there? So do you see that all this is idle time? Because processor 1 cannot start job G until E is finished. And at 25 hours, finally E is done, and then we say, all right, yep, you get job G for 1 hour, and the other guy's idle for the last hour, and we're done at 26 hours. The whole job is done in 26 hours, but we had a few idle hours. Is a bad planning. Does that make sense there? Oh, we did that? Questions on that? So I just want to be straight with you. People miss these like crazy, and they lose whole grades. Because there's like 4 of them, and they're worth like 8 points each.
How many, like, 3-player...
There'll be like 1 3-player. You look at practice. Each like practice. I think there's 1 3-player, 2 2-player. I don't know, something like that. You look at practice. There's like 1 3-player, I think. Anyway, but the fact is, people just don't practice enough. It won't work for you to just watch me do 1 or 2. You need to go home, ask the computer, do them without looking at the multiple choice, practice and practice. But if you don't do that, if you just kind of tell yourself little lies like, yeah, I kind of got it. It takes practice. If you just come in and just try it, you'll miss them, and I don't want to do that, but 8 points. There went 24 points, right? There went 2.5 grades, right? And even though you basically know the idea, if I interviewed you, you would say all the right things, but you really can't crank it out because you haven't practiced enough. That's what happens all the time in this material. There's a difference between understanding it and really being able to do it. I understand how to hit a tennis ball. I played on the little junior college tennis team. But there's something Rafael Nadal knows about hitting that tennis ball that I don't know. Have you seen him in the French Open? He's going to win it for sure. He's killing everybody. Anyway, so there's a difference between knowing it and really being able to do it, right? So make sure you don't just know this material, but you can do it. And the only way to know that is do it. Really do it. Really do it several times until you can get them right? Until you can get them exactly right. So this program will give you more and more and more and more. But don't look at those. Don't fool yourself. Don't just look at those multiple choice, because those won't be on the test. Don't just look and go, oh yeah, I see that's right.
Do them yourself.
Yeah, don't just cover that up. Do it yourself all the way without looking, and then see if it's right. And if something's wrong, then fix it. So that takes time. Many are not willing to give that kind of time. So 2 by 2s, and then we'll do the 3 by 3. So they get uglier. These ones need, there'll be like 2 of these, 1 3x3, and something else. All right, so try that one. So same kind of thing. All the rules are the same. It's still 2 processors. What was it? Decreasing time. Decreasing time is your precedence thing. So same kind of thing. So try another one. Different numbers in the arrow diagram. So try that one. See what you can do. Really encourage you to try the one that's on my screen here, so you can make sure you can do them and not just look at the multiple choice answer. Try that one. Let's give it a go. So if you're looking at jobs A, B, and C, those are our options, right? Processor one's going to go first. You always start with the P1 and then P2. So which job will he take? Well, it's decreasing time. So that means you start with the highest time. So start with the 9, huh? So it has nothing to do with the alphabet or anything like that. It's just highest, at least this one. Some of them will. Sometimes they really will say go alphabetical. But this one says decreasing time. So start at the highest time. So that'll be C, 9 hours. Does that make sense? C will take 9 hours. Now, what's the next? So what about processor 2? What job will he work on? The B job, because that's higher than the 1. 2 is higher than the A, which is 1. Right? B is 2, higher than A, which is 1. So B first, but that's only a 2-hour job. So make sure you have, this is like a real ruler, right? If this is 9, this is only 2. You know what I mean? You guys want to map that out. And then A, so once he's done with B, so remember, you go forward in time to the first completed task. This one's done. This task is done. So processor 2 is saying, I'm ready for another job. Boss, give me another job. What's available? A. So give him job A. That's only a 1-hour job. That'll take him to 3 hours. Right? A was only a 1-hour job. And then after 3 hours, he comes back to the boss again and says, I'm ready for another job. So right now, let's be clear. So you always want to remember where you're at in time. I'm at 3 hours. What's going on? A and B are done, and C is being worked on by processor 1. Right? That's the case right here at time 3 hours. At time 3 hours, A and B are done, and C is being worked on by processor 1. Right, that's the case right here at 3 hours. Okay, now, what's going to happen from here? What's available? Look with me at that chart. What's available to be worked on?
D.
Only D. Only D. Why? Well, because you can work on D when you finished A and B are done. So
Not done yet.
they lead to, E is not available because C is being worked on but not done. Right? Right at 3 hours. Remember where you're at in time. 3 hours. Right now, you're in the middle of project C still. C's not done, but A and B are done. Does that make sense? A and B are done, C's not done. So E's not available. Only D's available. 12-hour job, give it to D. 12, take 3, add 12, puts you at 15. Right? D's a 12-hour job. Okay, now, what do we do? Move forward in time to the next completed task. So from 3 hours, move forward, right here, 9 hours. The next completed task is at 9 hours. Good? To there. So I'm at 9 hours now. At 9 hours, go to the arrow diagrams. Job C is done. D is being worked on by processor 2. That's the state of things at time 9 hours. What jobs are available? E is available. E is available. Right? In fact, E is the only thing available. You with me? We can't work on G till we got E done. We can't work on F because D's not done yet. D's being worked on at 9 hours. You're in the middle of D. So the only thing available is E. E can be worked on. That's an 8-hour job. So that'll go to 17, go a little past 15. So I went past the 15 because 9 add 8 because E is an 8-hour job, it says. So add 8 to the 9. 9 plus 8 is 17. Does that make sense so far?
Not 18.
So now go forward in time. Is that okay? Questions on that? Go forward in time to the next completed job. Here we are. We're at 9. Boom, right there at 15. So go forward to the 15. And then what's done at that point? D is done. Get rid of all this stuff. So let me get it. So A, B, and C, and D are all done at 15. And E is still being worked on by processor 1. That's the state of things at time 15 hours, isn't it? Y'all with me? B, A, and D are done, and C. B, A, D, and C are all done at 15 hours. E is being worked on by processor 1, not done yet. So what's available for this person who now wants a new job? Only F. G's not available because he's not done. Only F. F's a 5-hour job. Give him F. Take him to 20 hours. Right? Go forward in time to the next completed task. That takes us up to 17. So we're at 17. At 17 hours, E is done. Job E gets finished. And F is being worked on by processor 2. What's available? G. 6-hour job. So that's a 6-hour job. For G, 6 hours would be 23. And then those will be idle. Was that 3 hours? 3 hours idle time. That's not bad. That's pretty good management. Only 3 hours wasted. Is that good on that? Make sense? Questions on that? Ready for a 3-er? Okay. 3 processors. And this, what just happened there? I just hit the wrong button. Yeah. 3 processors. All right. Is it all good on your screen? Yeah. All right, so there's the priority. It's not decreasing time, it's that. Does that make sense? That's the priority list, but that's not primary. It's primarily the arrow diagram. 3 processors. So we're going to have processor 1. Maybe I better use their line. So processor 1, processor 2, processor 3. 3 processors. So these are harder to track with.
Imagine if like 50 people.
Yeah, they have computer programs that do that. All right, so give it a try. Let me let you start. I think there's value just in starting the thinking on your own. So we're about to start, right? Processor 1, you go first. Where do I go up here and go, I'm looking at that? No, never look at that first. Never, never, never. It's always first here. So it's A, B, and C, right? We got to start with A, B, and C. So, okay, well, which one's first? A or B or C? Do I say, well, C, because that's the highest time? We're not doing time on this one. This is not decreasing time. Right? It's this. That's the priority list this time, not decreasing time. Now, coincidentally, it's still C. But it's a raw coincidence, which will not likely happen on the test. So does everybody see? Remember, so they have different ways of doing the priority.
Because
Sometimes they'll give you letters, sometimes they'll say decreasing time. Tomorrow we're going to do critical path, which is the best of all.
because D can't be done.
Yeah.
The next one on
Right.
the list is.
Yeah, my only options are A, B, and C. So I'm only looking at this list going, which of those three? Right? Because I have to start with A, B, or C. I cannot start with D or E or F or G. I don't care where they're out in the priority list. The arrow diagram rules. Is everybody catching that? So it's first arrow diagram, and then whatever options you have from the arrow diagram, then you take them to your priority list, whether that's decreasing time or just a listing of letters or tomorrow critical path, whatever. So I'm saying it's A, B, or C. So where are A, B, and C on my priority list? Who's first among those three? I don't care that D is in the front. I can't do D now. C comes before A or B. So C is up here, which also happens to be the longest time, but raw coincidence. Who's next? A, which also is the next time. Boy, so you could really get lucky in this one and not realize that you don't know what you're doing. So it is CAB by the way they put the priority list. That make sense? CAB, 3 processors, right? They'll all start with their jobs. Okay, take the next step.
After C.
Okay, so you want to be really, really careful here. You got to really keep where you're at in time. Right? So don't just kind of like look at the whole thing, but go forward in time to the first completed job. What's the first completed job? What's first completed job? Right here. B. Processor 3 is going to be the first one to come back to the boss's office and say, I'm ready for another job. Right? So then be real clear at that point in time what's going on with the arrow diagram. So where are we? So B job B is done. A is being worked on by processor 3. C is being worked on by processor 1. There's where we're at in time. At 5 hours. You guys with me? You got to put yourself in time. Where am I in time?
Well, wouldn't you go to D next? With A, because C's not done, and C and B can't go until they're both done at the same time.
So what am I going to do how about this? You may be right, but to be really focused and clear, what am I going to do with processor 3 right now?
It's idle time.
Good, exactly. So everybody see, I have no job available for processor 3. Why? How do I know? Well, look at the arrow diagram. Right now, B is done. A and C are being worked on. What's available? Nothing. D's not going to be available until A is done. A's not done. Right, not at 5 hours. Right now at 5 hours, A is right here. It's got 3 hours left to be worked on. A's in process. And E's not going to be available until C's done. And at 5 hours, we're right here. C's only a little more than half done. So there's nothing available. Everybody see that? So this is, so I'll go idle time. Now, why do I only go up to, it might go further, I don't know, but I just go up to the next completed job and see if things change. So I'll go up to 8 hours in hopes that something will change. Now, job A is done. So I'll go up here and go, okay, job A is done. Right? A and B are both done. I'm kind of scribbling around here. A and B, let me change the color, make it easier. A and B are both done. At 8, I'm in 8 hours now. Everybody with me? Everybody seeing where I'm at? At 8 hours, A and B are both done. C's still being worked on by processor 1 at 8 hours. He's got 1 more hour to go. I'm at time 8 hours. Right? So what's going to happen right now?
D.
Who's available? Is job D available?
Yes.
Yes. Job D. Is anybody else available? Because you got to look at all. If you have options, then you got to go to your priority list. Is anybody other than D? Is E available?
No.
No. You're right. E is not available. Does everybody see that? Because you might think, well, B's done. You just go around it. No. But C's not. You got to have, remember, the arrows mean you got to have both B and C done before you can do E, and C's not done. So at time 8 hours, C is right here, has got an hour to go still. He's not done. So E's not available. Right, good. So the only thing available is, if processor 1's on this one, is D. D is the only job available. Okay, well, who's going to get it? Well, how many processors are ready? 2 and 3. If they're both ready at the same time, you give the starting number. Processor 2 will get it, because he's before 3. Does that make sense? If 2 people are available at the same time, you just give it to the, if it's 1, that's before 2, and 2's before 3. So processor 2 gets job D, which is a 12-hour job. Takes him all the way to 20 hours, from 8 to 20. He gets job D. Does that make sense so far? And another hour of idle time for processor 3, up to 9. I'm only going to go up to 9 hours, though, because then something else is completed. I'm hoping that things will change. Is that good so far? I move up to the next completed thing, up to 9 hours. So what happens at 9 hours? Let me fix the board here. At 9 hours, C is finally done. And D is being worked on by processor 2. So what's available? What jobs are available at 9 hours? At this point in time, what's available? E. Only E is an Edward. E. Not F. Not G. E is the only job available. Huh. Who's going to get it? Which processors are available? 1 and 3 are both ready for a job. You always go with the lower number first. 1's going to get it. 6-hour job. 9 add 6 will be 15, about right there. E to 15 hours. And processor 3, more idle time. Up to 15 hours. Maybe I should make this a little longer.
So,
What's that? Question, Cole?
no, I was.
Okay, think about next step. Yeah, okay, so we good to there? Is that making sense?
So wouldn't processor 1 get G2 as well, G as well?
Yeah.
Yeah.
And then P3 will have idle time until 8 and
We'll just be sitting around, basically.
Yeah. P3 is never going to work again, I think.
they don't.
Yeah, we good so far? Is everybody seeing that? Making sense? Yeah, so next, so after the E, after E is done, at 15 hours, E is done. I come down here and cross off the E. Then, at that point, and then D is still being worked on, what's available? Only G. And both processor 1 and 3 are available, but processor 1 will get it. 2-hour job, G, take him to 17 hours. More idle time, processor 3. At 17 hours, this is done. What's available?
Nothing yet.
Nothing, because F's not available till D's done. Nothing. So these guys are both idle. Up to 20 hours.
And then P1 gets
And then finally D's done.
F.
And job F will go to P1 for 1 hour, 21. And the other 2 will be idle for that last hour. Did you trace with that? A lot of idle time. So that's where management looks and goes, maybe this would be more efficient with 2 employees. 3 employees, probably overkill. I don't know. You'd map out the different possibilities and on you'd go. Does that make sense on that? Questions on that? So tomorrow we're going to do, we're going to make it even a little more complex because we're going to have a higher, more difficult algorithm called the critical path algorithm. A smarter algorithm that looks down the road and says, pick the road with the lowest numbers. That's the smart way to do things. And then we'll take our practice test. And then the day after we take the real test. So you really need to have these mastered. And I've described what mastered means. You can really do them, right? Don't fool yourself about your real ability to do them, right? You have the practice exam. You have the tutors available 2 hours before class tomorrow. He'll be there to help you go. He'll go over these with you, train you on them. He's had this class before. He's real good at this stuff.